G, and this is T, and then this is D, and this is C. So this is generation, this is distribution, and final consumption. So this is overall, let's say, structure of power system. So you already know by just looking at these names what happens in each of these domains: generation, transmission, distribution, and consumption. So the course, the power system, we are mainly focusing on this one. So this is the transmission part will be the focus of this course. Okay, so inside transmission, what happens? Now, as you know, any power system will have power generation. Then whatever generated power is put onto the transmission network, and then it is distributed to the consumer. So, of course, because if you study transmission work, you can apply that for studying the distribution network, but more of so focus will be on the transmission network.
Okay.
So, what is there inside the transmission network? So, for generation, it is more like generation units, and the voltage level is about 11 kV. So, the power is generated in 11 kilowatts, and then it is stepped up, and for transmission, it will be high voltage transmission, somewhere as high as 400 kilovolts, and then this is a transmission network. Then the power is going to the distribution network, where it is 33 kilovolts, and finally when it comes to the house, it is your 230 volts or 440 volts. Okay, so this is in the case of 3-phase, and this is in the case of 1-phase. So what happens in this? Okay, so first thing is, when you generate, there are, so here let's say in the generation 100% is generated. So by the time power goes into the transmission network and then crosses to the distribution network, already there are some losses here. So the losses are roughly about 5 to 10%. So let's say here there are losses of about 5%. Then the remaining 95% comes to the distribution network. Again, there are some losses here in the distribution network, which are somewhat more significant because of the low voltage nature. So from 95% losses, the losses might go up to, or from 95 this one, so let's say the losses are as high as 50%. So we get about 95 minus 15, that is about 80%. And then even in the end consumption, there is a lot of wastage. So one part of this course is how to reduce these losses. First of all, how to account for these losses, and then reduce losses. So that is one thing we'll be seeing. So I hope you are able to follow whatever I'm telling. If you have any doubt, you want to stop in between. Okay, so let's continue. Go back to my diagram once again. So now what is the total generation capacity? So total generation capacity. So it is about 305 gigawatts. And what is the peak demand? So the peak demand is somewhere about 160 gigawatts. So first thing you should think about is, if my demand is 160 gigawatts, why do I require 305 gigawatts of installed capacity? So the reason is, you think of it as a supply. So all the time, all the generators may not be working, and then the location where the load is available and the location where the generation is available may not be the same. So to accommodate for that, some extra generation capacity is needed. But if you see, it is almost double. So the peak demand is 160 gigawatts and the generation is almost double. So near to double is actually exactly 320. So near to double. So how to reduce this gap? So why unnecessarily go for large generation and to meet the peak demand of 160? So in spite of all these things, there is also some kind of deficit. Okay, so unable to meet the peak demand. Okay, so that is called peak deficit. So this is again typically in the range of 1 to 5 gigawatt. Okay, so on one hand, so much of capacity is installed. On the other hand, not able to meet the peak demand. So what might be the reason? So the reason be that there is some limitation in the transmission and distribution networks. So as we increase G, we should also increase the transmission network and we should also increase the distribution network, so that we are able to supply the entire generation to the customer. So this is also one part. That is also highlighting the importance of the power transmission and power distribution. So as I said again, this transmission and distribution will be the focus, mainly focused on the transmission. Okay, so coming to transmission, let's do some kind of quick analysis. So that is business case for transmission. So consider that there is a power transmission line. So when you go out on the road, you are able to see some kind of towers like this. And then there are some lines like this. So what we want to do is, we want to do some kind of transmission network. So typically you can consider 400 kilovolts. For a 400 kilovolt lines, the power generation capacity or the power carrying capacity will be about 500 megawatts. So that means if I measure the power flowing in this line when it is fully loaded, it will be about 500 megawatts. So now I can make an estimate in 1 hour how much power, so or energy in 1 hour. So I can just simply multiply this. So E equal to 500 megawatts. So this I can simplify. I will say 500 into 1000 kilowatt hours. Okay. And as you know, kilowatt hour is nothing but 1 unit of electricity. So what's the price of 1 unit of electricity? So if you typically assume that the price of 1 unit of electricity is about rupees, then in 1 hour, how much energy is stored by this particular line? So I can just multiply that. So cost of energy transported. So that will be 5 lakh. So I have 5 zeros here. So 5 lakhs into 6 rupees. So that will be 1 30 lakhs per hour. So now you can calculate it for, I just take 20 hours because it is easy to multiply, and because all the time the power may not be full in that line. So just to make the calculation easy, I am taking 20 hours per day. So cost of energy transported will be 30 lakhs into 20 hours per day. So this will be how much? 600 lakhs per day, or you can say 6 crores per day. So this is the number. So whenever you see a very large transmission tower, so you should get this image that every day it is transporting the energy worth 6 crores per day. So this is in rupees. So for doing that, it's actually not generating the that much energy, but it is only helping in transportation. So in doing that, whoever is installing the transmission tower can ask for some TSC, that is transmission service charges. So percentage wise, I can say that if I transmit this much amount of energy, this much percentage you have to pay me as a transportation charges. So similar to vehicles transporting some raw materials or vehicles transporting some goods. So this is like we are using the transmission tower to send the power. So transmission service charges. So even if you take 1%, so typically I already said the losses themselves are about 5%. So 1% of transmission service charge is not very high, and it is like the normal price that is there. So if you take 1% transmission service charge, so earlier remember they are transmitting 6 crores per day. So 1% of that you will get 6 lakhs per day so whoever is building and running the transmission tower will be getting this 6 lakhs per day, not just one tower, the transmission line itself. So if I want to calculate per year, so again as an approximation I will consider, so you have 365 days, so if I multiply 6 lakhs into 365, so how much is that? So I'll use a calculator. So approximately you're getting 2190 lakhs. Okay. So or you can just round it off to 20 crores. So this is the revenue. So I hope up to here everybody is clear. So let me quickly revise what I was telling. So I go back. I'm just doing a quick revision. I was talking about business case for transmission. Consider a transmission line. First I want to calculate the cost and benefit. So right now I'm calculating the benefit. So these are the, we have assumed voltage level of the line and then power capacity of the line. In that case, energy carried in 1 hour, then the cost of that energy carried we calculated per day. So then we got 600 lakhs per day or 6 crores per day. Then assuming 1% transmission service charges, we get about 6 lakhs into 365, or approximately I round it off to 20 crores per year. So this is in rupees. So this is the revenue. Okay. So is up to here, is everything clear for you? I'll wait for a couple of minutes for you to think about it. If there are any questions, I'll be glad to answer them. So this is the question, what about length of transmission line? So let's do that. Let's do the cost. Okay. So let's consider 100 kilometers. So for 100 kilometers, so we have a tower every 1 kilometer, for example. This is again just a very rough calculation. So every 1 kilometer, if you have a tower, and then the line is flowing like this. So let's estimate. Okay. So what? This is again just a rough estimate. So to construct a 100 kilometer line, you have 100 towers. So approximately you will get 100 crores of investment. This is again a typical value. So normally what happens is this entire investment will not be spent right away. Mostly it will be based on a bank loan. Okay. So for large transmission companies, they will be bank loan. And let's assume the interest rate as 10%. Okay. So if that is the case, then what will be the interest? Interest will be 10 crores per year. So every year 10 crore rupees will be the interest rate. So this is again a very rough calculation. Now in the previous example, this is interest is nothing but cost. The cost is 10 rupees crores per year. Whereas the revenue, so we just calculate crores per year. So finally, what is the profit? So it will be crores per year, and this will be for next 25 years. So because typically the age of this transmission tower is about 25 years. So based on this, now you can see that it is very good to go for new transmission lines. So that's why again going back to my previous figure, generation, transmission, distribution and consumption. Okay. So the current scenario, the generation is growing very fast. Okay. So whereas the transmission and distribution are not growing equally fast. Of course, transmission and distribution are also improving, but they are not improving fast enough. But given the earlier example, it is very good time for transmission network to expand and distribution network also to expand. Yeah. So any questions so far? So if there are no questions, let me continue. Yeah. So now, whatever diagram I have drawn, this is the old structure. Okay. So what is the new architecture for? Okay. So you have generation, you have transmission, you have distribution, and you have consumer. Now near to the end consumer, what is happening is we are getting backup power and renewable power. So for consumer is having a rooftop solar system or rooftop wind power generation, then some kind of renewable energy is being exchanged at the end consumer level. And also there will be a backup power like a diesel generator they may have, or they may have some kind of a local generation plan. So that is about one big change. As a result, earlier the direction power may be like this. Now the power direction can also reverse. So the end consumer may actually produce more than their load and may send the power to the distribution company. From the distribution network, the power can go to some other customer. Okay? So because under each distribution customer, there are thousands of customers that are there. Okay? So this is a two-way direction. Similarly, the distribution network themselves will have a renewable energy. So there is some kind of renewable energy coming at the DISCOM level also. So instead of getting a power from the long distance generation plant, I can set up a local generation and generate my own power and then supply it. Okay, so this is another challenge. So between transmission and distribution also, so typically the power sometimes can also enter from distribution sector into the transmission sector. This is another problem. And here of course the power is unidirectional because by definition you are generating power. So you are injecting power into the transmission. Now there could be a grid scale renewable energy. So again major wind farms or major solar farms may generate the power and directly inject the power into the transmission network. So these are the new things that are coming into picture. Now the same thing may happen in a neighboring area. So let's say this is one area. So in the neighboring area there is another generator, there is another transmission network, another distribution network, and another consumer base, and they are having their own power system. So the same setup may be here also, renewable energy here, renewable energy here, and then they are exchanging power between the two networks. Okay, so this may be one state, this may be another state, and two states power transmission networks are interconnected. Okay, so this is this may be connected again. Okay. Similarly, two DISCOMs may be connected. So this is called interconnection. So whenever there is an interconnection, again it is creating more technical challenges. So because of this is what we call it as a new architecture of power system. Earlier it was very simple, but now because of this renewable energies introduction into the grid, the output power. So if I take a graph, so if I take time, so then it will be something like a straight line. This is output power of thermal plant. So you can actually control how much you want to generate. So let's say you are generating about 1000 megawatts. So this you can maintain constant throughout the day. Let's say this is 24 hours, 0 hours to 24 hours. You are able to maintain the power of a thermal plant. So, but what if I have a wind generation? So the wind generation, sometimes when the heavy wind is there, it is high. Sometimes wind is less, suddenly the power drops. So again power increases, again it drops, again increases, again it drops, again increases, again it drops. So it keeps on varying. So this is intermittent. intermittent wind generation. So it is technically a challenge of how to connect this with the grid. Also, if I have a solar power, so solar power, what happens? Morning around let's say 6 a.m. there's a sunrise. Slowly the solar power increases. In that also there will be some spikes like this. This is because of whenever there's a cloud passing over the solar panel, the power drops. So something like this. Then just by evening 6 p.m. the power again goes back to zero. So this is the example of solar power. So when you integrate solar power and wind power into your network, the total generation will become variable generation. So that is another challenge. So if I go back here, so because of this renewable energy and all, so generation is becoming variable. So similarly, consumption also becoming variable because this is also the renewable energy is connected to the consumer, and consumer anyway is all the time variable. The load is keeping on varying. So the supply is variable and the demand is variable. How you are able to transfer power from variable generation to variable load like this. So this is another problem. So this let's call this figure as problem 1. That is intermittent power, intermittent generation. So another problem is markets. Okay, so problem 2 is markets, power markets. So let's say I go back to this grid. Let's say this generator, the cost is 5 rupees per unit. Whereas this generator, the cost is only 3 rupees per unit. So now I am a distribution company in this region. Okay. So instead of buying power from this generator, I want to buy power from the neighboring region's generator because there the cost is less. So the power, either the power will flow from here to this place to down to this place like this, or the power will flow from here to here. So how to enable buying and selling of power between two different regions? So this is another problem that is coming because of this system. So for example, the buyer is in let's say AP and seller is in Gujarat. So how to make a power transfer between AP and Gujarat? So across different regions. So this is another problem. So these are problems. These kind of problems we can study in this course. So another problem, let's write it down. That is stability of the grid. So you might have heard about July 2012 North India blackout. So the entire northern India of the power grid got disconnected for close to 1 day. There was no power anywhere in the country. So that is the issue of loss of stability of the grid. Okay. So in a electrical network, all the time the supply and load balance needs to be maintained. And if the balance is not maintained, some of the lines get overloaded and then the grid will be unstable. Okay. So how to address the stability of the grid? Okay. So this is also some part we will cover in this course. One thing the concept of and push model of supply. Okay. So that means what is the meaning of pull? So pull means the user takes. Okay. So push means the supplier gives. So now if you look at the power system, so the power system is actually which model? Is the power supply given to you or is the user taking the power supply? So the answer to this is power system is pull model. That means the generation has to follow consumption. If C is decreasing, G has to be decreasing. Okay. So this is the full model of the network. So again, this also we'll see how it works. Depending on the changes in the load, the changes in the generation has to be made so as to maintain the balance between these two. Okay. So that is why it is called a pull model, and this also affects the stability of it. Okay, so let's continue. So how does, see what kind of problems occur? So another problem I have researched 3 problems. So another problem number 4 is scheduling. So scheduling means what time, how much to generate. So this is another question. So we need to schedule the power. So I have to inform the generations how much to generate at every instant of time. So this is another problem that we are going to study. So there are some again some more problems, 5, that is technical problems, that is maintaining grid parameters. That is maintaining the voltage. So avoid the high voltage or low voltage. This needs to be avoided. You have to maintain the voltage at all levels. So how to do that? Similarly, losses to be reduced. So cost to be reduced. So these are all some kind of maintaining the grid parameters kind of problems. Frequency. Frequency to be maintained near 50 Hertz. So power is generated at different frequencies. So frequency has to be maintained near 50 Hertz. So these are also different things. So that needs to be done. So that we'll also look at it in this course. Okay.
He knows how to use it.
So these are the problems. Not only this, we'll also see many other problems in the new kind of grid. So maybe I'll just wait here. I'll be showing this diagram on the screen. So looking at this, if you have any new questions or any doubts, I'll just pause for a couple of minutes. You can ask.
We can hear you.
So I'm just typing in the search Ministry of Power, and then if you open this website, you'll get something like this. So I invite all of you to, after this class, you can visit this website and then see that there are a lot of new information that is being made available in this site. Okay, so whatever I mentioned, generation. Okay, so what is the overview of generation, capacity addition, and all these things is there. then the transmission. So again, you have lot of information about what are the things inside the transmission sector. Then you have distribution sector. So there is a major scheme called Integrated Power Development Scheme, IPDS. So this also you can see. This is for improvement of distribution networks. Then there is some programs on rural electrification, energy efficiency, some training and some initiatives. So below you can also find something called Vijut Pravah and National Ujala Dashboard. So let's see. So first I'll open this one. So this is a site called Jntuk Moocs, and this one is showing the real-time prices. Okay, so if you look at the time price from power exchange for time block 11:45 to 12, that is just about 15 minutes back. Okay. So or as of now actually. So right now this is real-time prices. Date is 22nd November 2016. At this point of time, so all over the country, I can see what is the prices. So if I go up, so surplus power at power exchange is 1745 megawatt. So let me check. I hope you are able to see the screen. So and average market clearing price is 2 rupees 30, and the current demand met is 133 gigawatts. Okay. So remember I told the peak demand of India is 160 gigawatts. So right now, because it's afternoon time or just a morning time, so it is not peak. In the evening, this will go up to 160. Okay. Right now, 133 gigawatts. At the same time, yesterday it was 132, so almost equal. And shortage. The last part is shortage for yesterday. So yesterday, during peak, 1.356 megawatts or 1.3 gigawatts of power was shortage, which is about 1% shortage. Okay. So what is the shortage of India yesterday? It was only 1%. But then because this is winter season, the shortage is not very high. It is just 1% or so. But if you look at the same website sometime in the summer season, you can expect a lot of shortage. So right now, 12 o'clock in the afternoon time, I think most of the country, the air conditioning is not running because it's in the winter season. But imagine summer season, 12 o'clock, there will be a lot of air conditioners running, and then there will be a lot of power. So the demand will not be 133, it will be maybe as high as 160 also. Okay. So that is the first overview you are getting. This is from this website called Jntuk Moocs. So this website is open. This is real time. Anybody can open it. Now, if you go down, you will also find different states, okay, with different prices. Now, most of the places it is 2.6 rupees per unit. Okay, so 1 unit of electricity now it is costing 2.6 units, most of the North India. But if you come down to South India, so here you can see AP, Karnataka, Telangana, 3 rupees 68. Okay. So in the southern grid, the price is higher compared to the northern grid. Okay. So if that is the situation, then what can happen now? So if more power flows from north part of the country to the south, then we can reduce the prices. Because locally the price is 3 rupees 68. I can get power from the North India so that the power cost will reduce. So for that we need the transmission networks of the country to be interconnected. So you can also see for each region. So if I open this AP, a state-wise data is also made available in this website. So currently the price is 3 rupees 68, but yesterday it was 4 rupees 19 paisa. So compared to yesterday, it will show. And total, yesterday it was 6,855. So like this, you will get some more details. So I request all of you to look at this website. So how did I go to this website? So first is you start from the this website, that is Ministry of Power website. From there you have the link. So there is one more website called National Ujala Dashboard. So let me open that. So again, I hope you are able to see this website. So this website is again developed by Ministry of Power. So total LEDs distributed as on 22nd November 2016, 11:59. Okay. So what they are trying to do is to replace the existing LEDs with existing lights with LEDs. Okay. So you know that LED is having more light with less wattage. Okay. So by replacing the old light with the new LED light, we are able to get the benefit in cost. So here below you can see energy saved per year is this many units, 2, 3, 2, 287. So if I click on it again, it is showing. So cost saving per year, avoided peak demand per year, and then CO2 reduction per year. So like this, some data is being shown. Okay. So this is another portal. So again, I ask people to view this. Again, you can see Google Play button here. Not only this is data available on website, you can also install an app on your phone, and through that app also you can monitor what is the data. So most of the time you want to study some subject, sometimes you say data is not available. But nowadays a lot of data is made available online, so you can check that. Okay. So while we are doing this power system course, it is not just the theory that we are doing. We are also doing the practicals. So not only theory, we are also interested in getting some practical understanding. So another thing you see, this is GURV dashboard. So again I open it. So this website is again dedicated for providing the data on rural electrification. Okay, so how many villages are electrified? Okay. So on the right you can see GIS dashboard. So if I click on this, it might show some map or things like that. So I am myself not very much familiar with this. So I need to explore a little bit more. So in your free time you should open these things and then see. Okay, so now I think you are able to see some kind of a all India map, and then in this map there are some different locations. So each village, how it is electrified and all, I think that information is being provided in this map. So you can, this is a very detailed map. You can go to each region of the country and then different villages, what is the situation you can. So let me go back to the main website.
అది లేదు సార్ పెనాల్ పెట్టితే గత్తర ఏం కాదు సార్
జస్ట్ ఇలాగా పెట్టేసి మనం
నేను చేస్తాను సార్.
So there is another portal called Taran. So I just try to open to see what it is. So this is again showing about transmission network, I think. So let's explore this. Okay. So this Taran website is a transmission app for real-time monitoring and growth. So how the transmission network is expanding in the country, so that information you can find from this. Okay. So if you look at this screen, so transmission system under bidding, transmission system under construction, and completed transmission system. Okay. So how many lines are completed? So 242 elements, all these things like that. It is providing some information. So what are these three stages? First stage is bidding, second stage is construction, and third stage is completing the towers and then adding them to the transmission network. So in this is also available in the form of a app. So you can again load into this and then check for the details. So the point I'm saying is, so let me just summarize that to you. So let me just summarize that to you. I'll go back to screen sharing. So first go to the Ministry of Power website. So this is a government website. So there you find a lot of information. So one is Jntuk Moocs, and the second one is Ujala, and the third one is Tarang, and the fourth one is, what is it called? Garb, I think. This is the rural electrification. So a lot of information you can find on this particular website. Okay. So this is the first thing like you can try. So another place you can go, CEA website. That is Central Electricity Authority. Okay, so let me show that to you. So I'm going back to the browser view. So I can go to Electricity Authority. Monthly reports. So executive summary, monthly generation review, monthly power supply position, and quarterly reports and annual reports. Okay, these are the different reports that we have. Okay, so a lot of information you get. So I can select the date, and then I think it will be showing the report of that date. So latest was November 17. So this, like this, you can get the data. Okay, so this total generation in each region of the country. Okay. So this is for the date of 17th November 2016. Okay. So what is the actual generation? What is the demand? All the things. Okay, you are able to see. Okay. So let me go back to my screen. So you get yearly reports. Okay. So these are so many these things. Okay. So other two websites I'll also mention. You can go to Power Exchange India Limited website, or you can go to India Energy Exchange. website. So here, so there are a lot of data available. So you can also go for discom websites. So there are close to 100 discoms in India. Okay. So discom means distribution company. Okay. So these are the companies which are distributing the power. So again, you can get some things. So so basically, the idea is that lot of information on power sector is now available. So online. So make use of it. So try to, since you are doing this course on power system analysis, try to visit some websites, okay, and then try to gather some information, learn about the practical aspects of power sector and all these things. So again, maybe I'll just take a 2-minute break. If you have any questions, you can ask. It's not a stable energy, it is an intermittent energy. Depending on the weather conditions, depending on the time, the amount of generated power is continuously fluctuating. So that's another challenge of running the new architecture. And it also enables the power flow between two regions. So a discom of one region can buy power from the generator of another region. So how to enable that? So this is another challenge that we are getting in the new architecture of power system. So these are some of the new practical problems. Traditional grid did not have all these problems because they are able to, they had a unidirectional power flow, but then here the direction of power flow is bidirectional. There was not much of renewable energy and all. So because of that, this one. So what are the problems? So the first problem I mentioned is intermittent generation, and the second problem is about how to enable power markets. About stability of the grid was the third point. So you remember there's a blackout. So the power system is full model, so we have to maintain the generation. And fourth problem is how to schedule your power, and then how to maintain the grid parameter. So all these things are some of the new technical challenges that we want to meet. Okay, in the new grid. So in this course we will try to how to do that. Okay, so I hope that answers this question. Consider the cost of let's say apples. So the cost of apple in the one place may be different cost of apple in another place. That is because of the availability of the apples. Okay. So the cost of petrol will be different in one place to the other place and all these things. Okay. So that's why the cost of power is different. Also sometimes it also depends on the availability. So for example, if there is a lot of rains and all the rivers are filled and all the dams are filled, then the cost of power will be less. But then sometimes if the rains are not coming and then the water hydro stations are empty, then the cost will increase. Okay, so these are all different factors, because of that the cost is changing. And if that is the situation, and if you can actually connect the cheapest generator with the loads, so that the cheapest power, we can reduce the cost of generation. If we have a wrong circuits, so bring calculators to the class. So it will be not like today. So because it's an introductory lecture, I most of the time I covered theory. But next class onwards, there will be a lot of problems to be solved. Okay? So we'll do a lot of numerical examples. Okay. So, and as we go forward, I will also share with you the list of the lectures, and then we'll try to continue the schedule like this. So if that is the case, then I'll conclude today. I'll see you in the next lecture.